Hey everyone, so today we're going to be starting out Unit 3 with linear equations. So actually the first thing I'm going to have you guys do, if you could pause the video, try out these 4 problems and you're going to solve for x. And I will show you the answers in a minute. Okay, so now that you've solved these 4, I wanted to talk about kind of some different scenarios that are going to happen within linear equations that you guys have seen before. So one situation, I'll actually talk about this first one here. When you get 0 equals 0, or even at this step, 2x minus 4 is equal to 2x minus 4, or 0 is equal to 0. This is going to be the answer of all real numbers. And you could put this symbol for all real numbers. I'd rather you do that than say ARN. You could just get an answer, right? X equals 20. This is called a conditional equation, and that just means under the condition that x is 20, we get an answer, and this is a true statement. This one I always find interesting. A lot of people want to say no solution for this third problem right here, but when we get x equal to 0 or 5x equals 0, whatever it may be, when we divide by a number, 0 divided by a number is still 0, okay? Now, one that's a little more interesting is the last one here, which what happened, we got negative 4 equals 0. This is a false statement, right? Negative 4 is not equal to 0. So this is a no solution, and you can either write no solution or you can use this symbol. Okay, so now we're going to jump into a little bit tougher examples here. Some with fractions, some with decimals. I just want to clear these up for you guys. So if we take a look at the first one, I just wanted to remind you about distributing, being very careful here. And minus 10x plus 14. Okay, so we distribute and then we're going to get like terms together. And as you guys are solving this, kind of no matter what steps you took, hopefully you're with me here, 28x equals 28. We divide by 28 on both sides and we get x equals 1. How do we check these answers? You guys always like having that check, right? Take x equals 1, plug it into the original, and make sure it's a true statement. I always encourage that for a quiz or test. Okay, let's take a look at one with fractions, okay? Obviously, you could leave the fractions, kind of deal with it. My recommendation is multiply through by that least common denominator. So right now we have 6, 1, and 3. So overall, my least common denominator would be 6. So multiply both sides by 6 over 1. And you're going to distribute that to every piece. And let's see what we get. If you can immediately simplify, feel free. I'm going to show my work a little more. So 30 divided by 6x minus 12x over 1 plus 6 over 3 is equal to 12 over 3. Now the goal was, and you could have originally written this, we get 5x minus 12x plus 2 equals 4. That original goal was we got no fractions left and we got rid of those denominators. We can get rid of the denominators because we have an equal sign, so we can multiply each side by 6. Okay, and let's see what we end up with here. We get negative 7x equals positive 2. So x is equal to negative 2/7. And just leave that as a fraction. And we don't need to put it as a decimal. I'd rather you leave it exact as a fraction. Okay, when you're all set with that, take a look at a decimal problem. Kind of same thing as fractions. You can leave them if you want, but my recommendation is just if you see that all of them have that one decimal spot, multiply each side by 10, and we can get rid of the decimal or move that decimal spot over one slot. So when we're multiplying onto things that are also multiplying onto parentheses, okay, we only multiply the outside number. So we're not going to also say 10x plus 20. We're just multiplying this, which will get distributed. So the 10 will impact the inside. So we're just multiplying the outside here. I get regular 5. Again, I'm moving that decimal spot over 1. And this is equal to negative 2 minus 4. And now we're kind of ready to go here and solve, and we don't have to deal with any decimals. So 3x plus 6 minus 5x minus 10 is equal to negative 6. Let's see here. Negative 2x minus 10 is equal to negative 12. And after all that work, we get x equals 1 again. Okay. So some problems we're going to dive into here, those are kind of your basic problems with, and then fractions and decimals might kind of throw you for a loop. The problems we're going to be trying below involve more than one variable. We often call these literal equations, where we have to solve for one variable, but there are multiple variables in the equation. So let's take a look here. We're going to solve for h. So I want you guys to treat every other piece here, every other variable that's not h, okay, like a number. So what we're going to do is try to isolate h. So we do our normal tactics here, which would be subtracting things that are added. So s minus 2b equals ph. And then we are multiplying by p, so we'd have to divide both sides by p. Okay, so final answer here, you could write it as s minus 2b over p, or you could split it up if you want, but you do not have to. Okay, if you guys remember, this is surface area of a prism, if you forgot. So that's solving for the height. Okay, so there's your two available answers, solving for h. And let's try out solving for b. I gave you one, capital B, by the way. This is the area of a trapezoid, 1/2 height, base plus base. Capital B is different than lowercase b, so just be careful here. And that 1/2 we can deal with in a couple ways, right? So I personally want to deal with the 1/2 by just multiplying both sides by 2. And then I would end up with 2a equals b plus b h. So again, I kind of want to just get rid of the fraction. You don't have to do that, but we definitely don't want to divide by 1/2. If we divide by 1/2, remember that's the same as multiplying by 2. So we don't want to get like a double-decker fraction. Next step, you can either distribute the h or you could divide the h from both sides. Notice it's being multiplied here. So I could have 2a over h equals b plus b. And your last step would just be to subtract. Be careful here, guys. In this case, we only have h over the first fraction. All right, I just want to show you an alternative here. Let's say you did distribute the h. You would have gotten hb plus hb. You would subtract little hb here. And then you would divide the entire thing by h. So this is also an answer that would work. And notice how it's slightly different, but if you split up the fraction, it would actually be the same thing. So I want you guys to know these are the same answer, and you might get something different from your neighbor, but same exact answer there. This one's actually just in a slightly different format as one fraction. Okay, so last ones we're going to do here, they're a little bit complicated because basically the variable is going to be in two places. So here are your steps if you'd like to look at them. We're going to distribute combined like terms. The biggest thing here is we're going to group the x's together, or whatever. Right here we're going to solve for x, but whatever you're solving for, you're going to group those to one side and everything else to the other side. Then we're going to factor out x and we're going to divide. So let's try this out here. Okay, so take a look at the first one. All right, we're going to distribute. So ax minus 2b equals 5x plus 5a. Remember, what we're looking for is x. Okay, so we're going to end up moving anything with an x to one side. So I'm going to add 2b over here, and I'm going to subtract 5x to this side. So let's see what we've got. I've got ax minus 5x equals 5a plus 2b. Okay, so make sure you're with me here. Again, we want to solve for x. The reason we can't just solve for this x is you would have an x on the other side of the equation, and so you wouldn't have actually have purely solved. You want to have x only by itself on the left or right side. So now that we have x's on one side, that's our first goal, we're going to factor out a GCF of x. And the right side is still the same. So now I have x times a minus 5, and that's equal to 5a plus 2b. So now that I have x times something, my very final step is just going to be divide by that entire parentheses. Okay, so I'm going to end up here with x is equal to 5a plus 2b over a minus 5. And we remember from last unit, we can't just cancel out a's or anything like that, since it would have to be the same binomial to cancel out, or the same factor. Okay, let's try another one here. Okay, so x over a plus 2 is equal to ax minus 1. You can kind of, I would probably put this over 1, because then you can kind of think of that cross multiplication idea, but it's up to you guys. Either way, that's one way that's going to happen. So x times 1 is x, and we get ax minus 1 times a plus 2. So again, we're solving for x here. We want to distribute. In this case, we're going to end up foiling. And the reason we're not done, yes, we have x here, but look over here, guys. We still have an x hidden on the right side. So we've got to solve this out. Okay, so we get a squared x plus 2ax minus a minus 2. So I distribute. Remember that next step, and it's up on the right there. Your next step is you're going to be subtracting anybody with an x. So we're going to move those to the left. So x minus a squared x minus 2ax. So again, I subtracted both of these guys, is equal to negative a minus 2. All right, so we distributed. We moved all the x stuff to one side, everybody else to the other side. And then we factor out that GCF. So x times 1, be careful, minus a squared minus 2a is equal to negative a minus 2. And now that we factored out x, it's x times something. We're going to divide by this entire parentheses on both sides. 1 minus a squared minus 2, minus 2a. Okay, so let's write our final answer here. With negatives, you're going to see it could look slightly different, so I'll show you what I have, but I think we can kind of make this look nicer. So this would be a valid answer. We can see if this factors and cancels. It's not going to in this case, so this is fine. You may see on a test something like this. If I were to factor out a negative from top and bottom, that would be what? Negative 1 plus a squared plus 2a. And canceled out those negatives, I think you could easily see a multiple choice answer that might look like this: a squared plus 2a minus 1. Kind of, I guess we could say prettier, less negative. So just warning, right? Those are both correct. I would give you credit for both. If it's multiple choice, you might see a slightly different option available. All right, we are going to save this last one here for class, where we're solving for x again. So thank you so much for watching, and please let me know if you have any questions.